Hello all, welcome to Matlab Simulink for Beginners Class 3. So in the last class, we have created our software component and we have connected the external inputs and we also generated two output signals. So in this class, we are going to further break down our component into smaller modules. As a next step, we have to create our software design for this hill control. So in this software design, we have to break down the modules and in the software design we should also give information that how many blocks we are going to have and how the interaction and things so on. Let's go to our software design. Before start doing coding in Matlab Simulink, what you need is an architecture and the second one is your software design. So this is our simple software design for the hill control. So yeah, this is our software component. So inside the software component, here we can see that we have four modules. So the first module calculates the trigger condition from passive to active. The second one calculates another trigger condition from active to ramp out. So the third class uh, is about to ramp out to passive trigger condition. And then here we have our state machine. So in this state machine, we have three different states, and the trigger conditions are coming from outside of this class. Yeah, this is our simple design for the hill control. Next, we see about the detailed design of each individual modules. Let's go to passive to active trigger module. Yeah, uh, this is a design for this class, passive to active trigger condition class. So here we have to calculate the trigger. So this trigger is set to true when all of the following conditions are satisfied, like the vehicle should be in a standstill and the brake is released and the gear is in the drive gear and the slope is upward slope, or the gear is a reverse gear and the vehicle is in a downward slope and the driver is present and seat belt is buckled. The driver door is also closed, and the slope is also within allowed limit, and hill hold control is not disabled. So these are the conditions we should check in order to set the active trigger. But here we have not received these two signals, so we will skip this. In our coding, we will skip these two requirements. This is the design of our next module, active to ramp out trigger calculation module. So inside this module, we calculate the trigger. If any of the following conditions are satisfied, then we set the trigger to true. So the first condition is the engine torque is sufficient to move forward, and the second condition is the active timer is expired. So the third condition is that the driver want to leave. His intention is to leave the car. So either he opened the door or he removed the seatbelt, uh, or he did this gear shift to N or P, or if there is any issue in the system, like it has detected a failure. So in such a case, we have to set this active to ramp out trigger. This is the detailed design of our third module. So inside this module, we calculate ramp out to passive trigger. So this trigger is set to true when we have reached the target price of 0. So this is the only condition inside this module. So this is our state machine design. So in our state machine, we have three different states. So in passive state, what we are going to do is like we are going to set the active filter control active flag to false, and we will set the target pressure to 0. And during the active state, we will set the active flag to true, and the target pressure is same as the hold pressure. And during the ramp out state, we gradually reduce the pressure to 0, and also we will set the active flag to false. So this is our state machine design. Let's go to the Matlab Simulink. Okay, in the Simulink, let's go inside our software component. Okay, let's create four different modules. So for that one, you go to the Modeling tab and click this Insert Subsystem. It is create the one module. So similar way, you create the four different modules. So third one, is our fourth one. Let's keep it here. Let's go back to our design and see what are the inputs needed for first module. So in our first module, we need a vehicle speed, brake applied signal, the gear, also slope, and the disable signal. So let's connect the vehicle speed and the brake applied signal. And what we need is the slope as well as the gear. And we need this disable signal. We know how to align this. Yeah, let's keep it here. Let's go back to the next module design. So here we need the engine torque and the timer. So this is an internal signal and the gear and the disable signal. Okay, let's connect these two signals first. So we also need the gear and the disable signal to this module. So how to do this? Because this is already used in this module. So like when you place your cursor here, your cursor displays a plus. So from here, click and drag and leave your cursor to your signal. So this will create a line like this. Similar way, you keep your cursor here, so that displays a plus, and then click and drag to here. Yeah, by doing this one, you can connect the same signal between multiple modules. We also need a timer, but this is an internal signal from our state machine. So for example, you consider the first output of this module is our timer, then click here and hold it and drag it to the last input of this module. Yes, like this, we can do it. Actually, here we cannot directly assign output of our module to input of this module. This will create a loop. So in order to avoid that, we need to introduce a delay. It's called a unit delay. So that means output of this component is used as a input of another module inside this software component. So that means we have to take a previous output of this module. So that is the meaning. So one cycle delay we will apply here. And yeah, let's go back to the third module design. So third module need a target pressure. Again, this is another internal signal which is coming from the state machine. So like what we did it for the input, like you keep your cursor here and click and drag it to the input of this module like this. And give a name for your input signal and output signal, like this is as a timer, and here as a pre-target, and as well as the input side. Okay, next give the meaningful name for the module also. I start with the software component name and the module name. Okay, like this. Give a name for other modules as well. Images are about to passive. And this is our state machine. And here we have two outputs. So these outputs are coming from our state machine. So let's connect it to the state machine like this, just drag and drop it. And this is our pressure signal. Okay, now we have connected our outputs. And let's connect output of all three modules as the input to the state machine like this. And give a name for here. Try to provide the same name. final trigger as well. Here you have to understand one thing, why we have input the unit delay here, but there is no unit delay here. Uh, Basically, this is depends on the execution order of the blocks. So here it's very clear that these three blocks should get executed before this class. Okay, so that's why we directly connected the output of this class as an input to this class. But whereas these two inputs are concerned, we are using output of this class. So that is the reason why we have put the unit delay here. So this is the end of today's class. In the today's class, what we have learned is like how to decompose one software component into smaller modules, and how to create a module inside the software component, and how to link the input and output, and also how to interlink between the modules, and how to use the why we have to use the unit delay. So these are the things which we have learned today. And in the next class, we see about uh, how to convert our detailed design into Simulink model. Okay, see you in the next class.